Hello, my name's Steve Young. I'm a Fellow of Emmanuel College and Emeritus Professor of Information Engineering at the University of Cambridge. My research interest is spoken language processing and in particular building conversational agents. You'll know examples of these like Amazon's Alexa and Apple's Siri. I've been working on this a long time. Indeed, I've been trying to talk to machines for nearly 4 decades. My wife thinks this is rather sad. I should spend more time talking to humans, but I find the topic fascinating. I built my first conversational agent during my PhD 43 years ago. This was a specialized telephone-based system designed to provide engineers in the field with up-to-date status information. You couldn't actually talk to it because back then we had no clue how to do speech recognition, and even if we had, the computers of the day were way too puny to be able to implement it. So instead, the engineer entered commands using touch tones via a keypad. The system spoke back to you using a dictionary of spoken words, stored as the parameters of a digital filter. To synthesize a sentence, the words were joined together and the prosody adjusted to make it sound fluent. The synthesis quality wasn't great, but it was intelligible and the system was usable. After finishing my PhD, it was clear that the real barrier to progress was speech recognition, so I started working on that. Now, speech recognition is very difficult for 2 main reasons. Firstly, there's huge variability in the way that people speak. 2 speakers will say the same sentence very differently due to differences in background, their accent, culture, their mood, and their physiology. Even the same speaker will say the same sentence differently each time they say it. The second difficulty is that there are no spaces between words in continuous speech. It's like handwriting in which you never lift your pen off the paper. So a computer that's trying to translate speech into words has to simultaneously figure out what each sound represents and where the words are, and this is hard. The solution is to treat speech as a sequential statistical pattern recognition problem and use training examples of spoken utterances and their transcriptions to learn to model the variability in natural speech and to decide which words are likely to follow each other. When we started using this approach in the mid-90s, we typically used about 10 hours of speech to build a system. They worked, but not very well. However, in the meantime, we've made much progress, and modern systems typically trained on thousands of hours of speech using sophisticated neural network models, and they work rather well. At the same time, speech synthesis has improved quite dramatically. The problem now has shifted from teaching machines to recognize a single utterance and generate a single response to teaching machines how to manage a whole conversation. The basic idea is to treat conversation as a game between the user and the machine. The user sets a goal and the machine tries to find the sequence of actions needed to accomplish that goal. And it does this using something called reinforcement learning. Every conversation it receives a reward, and it tries to maximize that reward by learning from the things that it did right and from learning from the things it did wrong. Although there's still a great deal to do, progress is being made. And over the next few years, we'll see conversational agents getting smarter and smarter. They'll move from being a gimmick to being an indispensable aid. And there'll come a time when we wonder, how did we ever do without them? Thank you.